How life began on Earth. Have you ever wondered how life on Earth began? How did this vast, beautiful planet, teeming with life, come to be? Today, we're diving deep into one of the greatest mysteries of all time, the origin of life itself. Buckle up, because this is a story 4.5 billion years in the making. A story filled with cosmic collisions, chemical reactions, and the tiniest of molecules coming together to create something extraordinary. Let's take a journey through time and explore how life emerged from the chaos of the early universe. Let's rewind the clock. Picture this: Earth, 4.5 billion years ago. It's a chaotic, fiery mess. Volcanoes erupting, asteroids crashing, and no sign of life anywhere. This was the Hadean Eon, a time when Earth was anything but hospitable. The planet was still forming, and its surface was a molten sea of lava. The atmosphere was thick with carbon dioxide, methane, and ammonia, with no oxygen to breathe. But amidst the chaos, something incredible was brewing. The stage was being set for life to emerge. As the planet cooled, water vapor in the atmosphere condensed, and it rained. For millions of years it rained. Slowly, the oceans began to form. These vast primordial oceans would become the cradle of life. But how? How did lifeless molecules turn into living organisms? Let's break it down. Scientists believe it all started with simple molecules. Think of them as the building blocks of life. Water, methane, ammonia, and hydrogen, these were the ingredients. But they needed a spark that would set the stage for life to emerge. That spark? It could have been lightning. In the 1950s, scientists Stanley Miller and Miller-Urey conducted a famous experiment. They recreated Earth's early atmosphere in a lab. And guess what? When they added electricity to simulate lightning, organic compounds like amino acids formed. Amino acids are the building blocks of proteins, which are essential for life. Could this have been the beginning? But wait, there's another theory. Deep in the ocean, hydrothermal vents spew out superheated water, rich in minerals. These vents are like underwater geysers, and they're teeming with life today. Some scientists think these vents could have been the birthplace of life. The heat and chemicals might have provided the perfect environment for life to begin. Which theory is right? We may never know for sure, but both are fascinating. Now let's zoom in even further. Life needs a way to store information, like DNA, but DNA is complex. So scientists think RNA might have come first. RNA is simpler, and it can both store information and act as a catalyst for chemical reactions. Imagine tiny RNA molecules forming in the primordial soup, slowly evolving into more complex structures. This is called the RNA World Hypothesis, and it's a key piece of the puzzle. Over millions of years, these molecules came together to form the first cells. These weren't like the cells we know today. They were simple, primitive, and probably relied on chemicals in their environment for energy. But they were alive. This was the dawn of life on Earth. The first life forms were likely single-celled organisms, like bacteria and archaea. We know this because of stromatolites, ancient rock formations created by layers of microbial life. Some of these stromatolites are over 3.5 billion years old. Imagine that. Life was thriving on Earth just a billion years after the planet formed. These early microbes were anaerobic, meaning they didn't need oxygen to survive. In fact, oxygen was toxic to them. Fast forward a bit, and we reach a turning point in Earth's history, the Great Oxygenation Event. Cyanobacteria, a type of microbe, started producing oxygen through photosynthesis. At first, this oxygen was toxic to many early life forms, but over time, it transformed the atmosphere, paving the way for more complex life. Without this event, life as we know it wouldn't exist. The rise of oxygen also led to the formation of the ozone layer, which protects life on Earth from harmful ultraviolet radiation. This was a game changer. It allowed life to move from the oceans to land, setting the stage for the incredible diversity of life we see today. Now let's jump ahead to around 540 million years ago, the Cambrian explosion. This was a period of rapid evolution when life in the oceans exploded in diversity. For the first time, creatures with hard shells, eyes, and complex bodies appeared. It was like Earth's first big experiment in life, and it set the stage for everything that came after. During the Cambrian explosion, we see the first appearance of many major animal groups, including arthropods, mollusks, and chordates, the group that includes vertebrates like us. This burst of diversity is thought to have been driven by a combination of factors, including rising oxygen levels, the evolution of predation, and changes in the environment. Of course, we can't talk about the history of life without mentioning the dinosaurs. These magnificent creatures ruled the Earth for over 160 million years. But their reign came to an abrupt end 66 million years ago, when a massive asteroid struck the planet. The impact caused a global catastrophe, wiping out the dinosaurs and clearing the way for mammals to rise. The asteroid impact created a massive crater known as the Chicxulub crater, off the coast of modern-day Mexico. The impact released energy equivalent to billions of atomic bombs, triggering wildfires, tsunamis, and a nuclear winter that blocked sunlight for years. This event, known as the Cretaceous-Paleogene extinction event, wiped out 75% of all species on Earth, including the dinosaurs. But life, as always, found a way. In the aftermath of the asteroid impact, small mammals that had been living in the shadows of the dinosaurs began to thrive. These early mammals were small, shrew-like creatures, but they had one key advantage: they were warm-blooded. This allowed them to survive in a wide range of environments, from the poles to the equator. Over millions of years, these early mammals evolved into a wide variety of forms, from tiny rodents to massive whales. And then around 6 million years ago, our own story began. The first hominins, our earliest ancestors, appeared in Africa. These early humans walked on two legs, freeing their hands to use tools and carry food. Over time, they evolved larger brains, developed language, and began to create art and culture. Today, Earth is home to millions of species, each playing a role in the delicate balance of life. From the tiniest microbes to the largest whales, every living thing is connected by a shared history. A history that began billions of years ago in a primordial soup of molecules. But the story of life on Earth is far from over. Evolution is an ongoing process, and new species are constantly emerging. At the same time, human activity is driving many species to extinction at an alarming rate. It's up to us to protect the incredible diversity of life on our planet, so that future generations can continue to marvel at the wonders of the natural world. So the next time you look up at the stars or take a walk in nature, remember this: you're part of an extraordinary story. A story of resilience, adaptation, and wonder. A story that began in the most unlikely of places. A young, chaotic planet that somehow gave rise to life. How did life begin? We may never have all the answers, but the journey to uncover them is what makes science so thrilling. And who knows, maybe one day, you'll be the one to unlock the next piece of the puzzle. Until then, let's celebrate the incredible story of life on Earth. A story that's still being written.